If you are running FastAPI with just Uvicorn main app, you might be leaving a ton of performance on the table. Today, we're testing different deployment setups to find the ultimate way to run FastAPI in production. At the end, I'll show you a bonus benchmark that might make you rethink how you write your FastAPI functions, so stick around. First, let me show you the FastAPI application. For this benchmark, I kept it super simple. Our FastAPI app has just one endpoint, hello world. When you access it, it returns a simple hello world message, no database queries, no complex logic, just a minimal setup. It's perfect for testing raw deployment speed. Now let's talk about how I set up the benchmark. I deployed my FastAPI app on an AWS C5 large machine. I chose this instance because it provides consistent performance unlike bustable T-series instances which aren't ideal for benchmarking. And it has two vCPUs so I can experiment with different number of workers. To generate traffic, I used a smaller T2 micro machine. This way the load test runs separately without affecting the FastAPI server performance. Both machines are in the same subnet, meaning they are on the same private network. This eliminates internet latency and router overhead, so we are measuring pure deployment performance. I'm using a tool called WRK to send a lot of requests. It will send 1000 requests at the same time. This will run for 30 seconds to see how the server handles it. The goal is to find how many RPS or requests per second can the server fulfill and what is the average latency or response time. Now let's look at the numbers. I tested different deployment configurations for our FastAPI application, measuring requests per second or RPS and latency. Starting with the simplest Uvicorn command, I got an average RPS of around 2591 requests per second and latency of 382 milliseconds. And next, I pip installed uvloop and run the FastAPI application with the same Uvicorn command. The performance improved. RPS jumped to 3188 and latency dropped to around 136 milliseconds. A solid boost just from changing the event loop from default async IO to UV loop. Next, I switched to Gunicorn with a single Uvicorn worker. RPS further increased to 4220 and latency dropped to around 120 milliseconds. Then I scaled up to 2 workers, and remember the server on which I am running FastAPI application has 2 virtual CPUs. This gave us the best balance, the highest RPS at 4769 and latency at around 159 milliseconds. I tried running FastAPI application with more workers. As you can see in the graph, it didn't improve RPS, only the latency was increasing, which is not desired. So what's the takeaway? For the best performance on 2 CPU machine, Gunicorn with 2 workers is the sweet spot. More workers don't always mean better results. Now before I give you the bonus benchmark, let me know what other benchmark I should cover next, and don't forget to subscribe if you haven't already. If you remember our FastAPI application, the endpoint was a coroutine, meaning it was defined using async def. Now I have switched our FastAPI endpoint from async def to a regular def and performance dropped. RPS fell to 3072 and latency jumped to 340 milliseconds. That's a huge difference. This happens because def endpoints run in a thread pool, introducing thread overhead. As a result, they don't take full advantage of FastAPI async capabilities. That's it, everybody. Thank you for watching.